Welcome to the RevHD Wheel End training video. This free course is designed to instruct participants on how to properly diagnose and correct various wheel end issues, as well as effectively install all wheel end components so that they perform safer and more efficiently. This training course is designed to show you how to make any manufacturer's seal last longer. In addition, we will cover bearing adjustment procedures for both manually adjusted and pre-adjusted hubs. This is the most comprehensive wheel end training course available, and it's free. Whether you're using RevHD components or other manufactured products, RevHD strongly believes it is important to teach the procedures that will create a safer environment both on the road and in the shop. If you're watching this video on the RevHD website, there is a link you can follow after this video that will take you to a short quiz. A passing grade of 85 or better on this quiz will earn the participant a certificate for this wheel end training course. Additionally, for RevHD Wheel Seal customers, passing this quiz provides a wheel seal warranty that includes the brakes. So let us begin. There are 5 leading causes of wheel end failure. Number 1. Improper installation, either damaging the seal or cocking the seal during installation or when docking the hub. Number 2. Incorrect bearing adjustment. Hub systems have changed recently, and there are now a variety of different bearing adjustment procedures required for different configurations. Number 3. Contamination. Not cleaning the spindle shoulder all the way back, or not cleaning the race where it meets the hub bore. Number 4. Worn or damaged components, such as a bad shoulder or hub bore, or reinstalling damaged bearings or locking nuts. Number 5. Clogged vent hole, either on the hubcap or the drive axle vent. This training course will give you remedies for all 5 of these failure modes and help you diagnose problems before they occur to ensure that the wheel ends you put together perform better, safer, and last longer. Chapter 1. Inspection and Teardown. If you know the seal has leaked prematurely or have other concerns associated with the wheel end, you may want to take a few extra steps as you take the wheel end apart to properly diagnose what went wrong. Note: a leaky seal is one in which the oil is beginning to drip down from the seal. If the seal is simply moist or damp, it does not necessarily mean you have a faulty seal. A little bit of moisture or dampness on the seal is okay. Begin by examining the hubcap. If the wheel end was using oil, the first thing you will need to do is check the add and full lines on the window of the hubcap. Too little oil can indicate a leaky seal or a leak around the hubcap gasket, flange, window, or plug. Too much oil can cause a seal to leak or cause oil to be pushed out the sides of the hubcap or the hubcap plug. Next, examine the hubcap plug itself. Check the vent hole located on the center of the plug. If the vent hole is clogged, pressure building up in the hub can blow out the seal, causing it to leak. Use a paper clip or other small instrument to unclog the vent hole. Note: it is important not to use anything that will make the hole larger, such as a screwdriver or pocket knife. The RevHD hubcap comes with a clog-resistant plug, which utilizes a bidirectional check valve, intended to vent pressure out, but also relieve vacuum when the hub cools down. Note: for the drives, always make sure to check the drive axle vent to make sure it is not clogged. Also check the drive axle vent for damage. An S-shaped vent hose can crack and allow contamination. Another thing to notice pertaining to the hubcap plug is discoloration. If the color of the plug has faded to a white or yellow, or the rubber has become soft or brittle, this could indicate heat damage, chemical damage, or dry rotting. It is recommended that you replace this plug with another plug made by the same hubcap manufacturer. Some other things to look for on the hubcap are leakage around the window. If an aftermarket window kit was installed improperly, you could have leakage around the edge of the window or gasket. If the bolts have been over-tightened or not installed in a crisscross pattern, a leak may occur. While most hubcap manufacturers offer window kits, Most wheel end experts will recommend that you simply replace the entire hubcap versus attempting to reinstall a separate window kit. The difference in cost is minimal, particularly when you factor labor into the equation. Lastly, check for cracks around the flange of the hubcap. Again, if the bolts were over-tightened or not installed in a crisscross pattern, cracking can occur around the flange itself. To help with these problems, RevHD has designed hubcaps with one of the thickest flanges on the market. RevHD hubcaps also have reinforced spokes across the lens to prevent breaking or cracking. In addition, RevHD are the only hubcaps to come with a heat check sensor. Included in every box is a heat check bolt, which will extend if the temperature of the hub reaches 250 degrees or hotter. At 250 degrees Fahrenheit, bearings will begin to show signs of damage. At 350 degrees, many lubricants can ignite. This sensor is designed to alert you before a potential catastrophe occurs. Remember to always use a new gasket when installing or reinstalling a hubcap. Never use silicone or other sealants on a gasket. The gasket should always be installed dry. After examining and removing the hubcap, next look at the locking nuts. There are single nut systems as well as traditional double nut systems commonly used today. Examine these nuts carefully. If it is a single nut with a clip or tabs, examine those items to make sure they were locked in place correctly. Here we see an example of a clip that was installed incorrectly. The top of the clip is on the outside of the nut. It is not engaged with the teeth of the nut. This could potentially result in a wheel off. Other common single nuts utilize tabs on either side of the nut to lock the nut in place. Inspect these tabs to make sure they are fully engaged and locked.
There's also the Axi-Lock nut that comes OEM on a lot of trucks, and it usually has these two little tabs on here, so you put the socket over there, it squeezes in on the tabs, and you can take the nut off. But as you can see, a lot of times those little tabs break off, and if they break off and it's not fitting inside of this hole anymore to lock it into place, you can have a set of tires that comes off. Then on the double nut setup, inner and outer nuts and the washers and the tabs, if you see nuts like these that exhibit chisel marks, sometimes you see this was a chisel mark to take the nut off. Sometimes you see chisel marks the other way where nuts was taking it to put it on. But when you see this, or you see rounded off edges where likely somebody put this on with an impact gun and the loose socket started to take the edges off of the nut. But this one was put on where the spindle threads actually started taking all the spindle threads out of this nut. If there's no threads inside of the nut, like this has threads inside of there, obviously if you have no threads in here, there's nothing holding the wheels on, and you could have a set of duals that comes off. So another thing you need to look at when you look at the backside of your nut, when we talk about bearing adjustment, we're going to talk about torquing the wheel and rotating the wheel and torquing it multiple times. When you look at the backside of a spindle nut, you only see a couple shiny areas on the back of the nut. There's a shiny spot here and here and here and here, but there's nothing shiny here and here. So the shiny spots that you see on the backside of the nut, those are the only parts of that spindle nut that are actually physically contacting the bearing. So when we torque it, so if you just torque it one time, those shiny spots, you're going to have a torque on this roller and that roller and that roller. But when we rotate the wheel around, the bearings will rotate with it. And once we torque it 3 times with those shiny spots, that's how you get an even torque load on all your bearing rollers. So when you go to the RevLock nut, the backsides are heat treated and hardened to fit up against the bearing. And so you're always, and the tolerances are a lot tighter than these stamped out nuts. And you're going to get a lot more even torque load on your bearing rollers. We still want people to get in the habit of doing it 3 times, just so they're consistently doing their bearing adjustment the same every time. If you have damage on your components like this, we need to change out this whole nut setup. If you're changing out the whole nut setup, you can upgrade it for about the same cost instead of using all 3 of these pieces to our RevLock nut. And this will last the lifetime of your truck or trailer. We only have to use 1 socket instead of 2. And it's a lot quicker. It's a lot easier bearing adjustment. Easier to teach somebody how to do it this way than to do it this way. And most people this way, they're old school and they're not going to do it right. They just do it by feel and they hit the nuts with chisels. We see it all the time. But this is, it's more likely you're going to be able to teach somebody to do it the right way using a single nut instead of doing it this way.
RevHD recommends always using a dial indicator after performing a bearing adjustment. However, if there has been an issue surrounding the wheel end you are tearing down, you may also want to use a dial indicator before taking the locking nut off to determine whether the previous bearing adjustment may have caused the issue. TMC recommends an end play of 1 to 5 thousandths on a manually adjusted hub and 0 end play on a hub containing a spacer. On this particular wheel end, we see the needle does not move when pushing and pulling back and forth on the hub. This indicates a bearing adjustment that is too tight. A bearing adjustment that is too tight can cause premature seal failure and/or bearing failure. Over time, it can also cause spindle damage and poor fuel economy.
To check it with a dial indicator, you always put your magnet on the spindle so we can put your needle on the hub. So when you push and pull it, you should see that needle move. And right here, it's not moving at all, but every one of these little every one of these marks inside of here is 1/1000th worth of bearing adjustment. So on it, if you're not seeing any movement like this, when we take this apart, this should tell you it's a Conmet wheel and there should be a spacer in there with no play. If we check this and it has play in there and we take it apart and there's no spacer, then you know that the job was done right. If this is moving between 1 to 5 thousandths. So if you have 1 to 5 thousandths in play in here, we take this wheel apart and there's a spacer in there, then we have too much movement. Somebody before you didn't do the job right, and that could be an indication of why the seal failed.
Note, 1 to 5 thousandths is roughly the thickness of a human hair. You can't feel it. Only a dial indicator can tell you whether you have the proper end play needed to prevent the seal and other components from failing prematurely. If the needle on the dial indicator was to move more than 5 thousandths, this would indicate a bearing adjustment that was too loose. This can also cause premature seal and bearing failure, spindle wear, and tire wear. If this were a pre-adjusted hub utilizing a spacer, which we will talk more about later, then 0 end play is recommended. Many technicians tend to overcompensate on the bearing adjustment and perform bearing adjustments that are too tight. This course will go over proper bearing adjustment in greater detail in a few moments. After removing the locking nuts and undocking the hub, make a quick examination of the seal itself before prying it out of the hub bore. In this case, we can see that the spring on the seal had slipped out. You will also want to check the face of the seal for dents that could indicate it was damaged during installation or when docking the hub. Also check the ID and OD of the seal for cuts or gashes, possibly caused by burrs on the spindle threads when installing the seal and docking the hub.
This one has a wear sleeve that's up here on the spindle, okay? So obviously we need to remove this wear sleeve. You'll see them either like this that have a back on here. Some of them don't even have a back. It's just a band that goes around without this backing plate on here. So one thing you have to do is we have to remove this wear sleeve. If that wear sleeve is on there and you try to push the seal up on there, your dimensions aren't going to be right and you're going to have a problem with that seal leaking. So let's make sure we take this off. So a couple ways you can take it off. It's a little harder on the steer axle. But most of the time, if it does have this backing plate on here and it's on a trailer axle, you can take a hammer, we can beat down on here, we can bend this down flat and hit on the top side of it. It'll expand the metal out just a little bit to where we can usually just tap it from the back side and it'll pop off. Sometimes on the trailer axles, you have access points where you can go behind the spider of your brake assembly and hit it from the back side and knock it off as well. To take this one off, it's going to be a little more difficult. We're going to try it with the seal puller.
If you are taking this wheel end apart because of a premature seal leak or other wheel end failure, it might be a good idea to mic both of the bearing journals on the spindle, particularly if this is a wheel end that has continued to give you a problem in the past. Mic the bearing journals at 3 and 9 o'clock, and then take another measurement at 12 and 6 o'clock. Most spindle or shoulder wear will be evidenced on the bottom of the spindle near the shoulder. If the difference between the two measurements is greater than 6 thousandths, it is recommended that you replace the axle or the spindle itself. No wheel seal will be able to fully prevent leaks with this degree of wear on the spindle. Cleanliness is always critical in every aspect of the wheel end. Use a wire brush and emery cloth to clean the spindle threads, and the spindle shoulder. Note, some seals have a thinner inner diameter than other seals. If the seal you have removed has a thinner inner diameter, then dirt, rust, and other contamination may have built up towards the back of the shoulder. The RevHD seal has a wider inner diameter than other seals on the market. This provides for more sealing surface area on the spindle shoulder. However, if the shoulder is not cleaned far enough back, the contamination can push on the seal or ride underneath the lip of the seal and cause premature seal failure. When installing the RevHD seal or any other seal that offers the benefit of a wider inner diameter, always clean the entire surface of the spindle shoulder.
This is the number one most critical thing you need to make sure that you clean up really good with our wheel seal. Since we're wider on the spindle shoulder, we're sealing up this whole spindle surface area, okay? So that old seal that we took off, you can see up at the top, the clean part on here, and then back here you got all the buildup in the dirt. We got to clean all this up all the way back to the flange, get all that contamination off of there. If we don't clean this up, and you push that seal on there, all that rust is going to push out on the inside of the seal, and it causes compression failure inside of the seal.
To remove the previous wheel seal, use a pry bar or other instrument to get between the seal and the inner bearing. Then pry the seal out of the hub bore. Some seals will be easier to remove than others. Rubber-coated seals are typically easier to remove than metal seals. There are tools on the market that can also aid in removing the wheel seal if you find that a pry bar is not sufficient. However, you should never use the bearing as a punt to knock the seal out, unless your intentions are to replace the bearing and the race. Once the bearing has been struck in this manner to remove the seal, it is highly recommended that you do not reuse the bearing or race. If you have loosened the outer cage of the bearing by striking it, you could possibly have a bearing failure down the road that could potentially result in a wheel off. Examine your bearings thoroughly. Inspect the rollers and the outer cage. Here is an example of a bearing that you would not want to reuse. Whenever you replace the bearing, you should also replace the race. Clean the hub thoroughly, using an emery cloth around the hub bore where the outside diameter of the seal will ride. Use this same emery cloth around the spindle shoulder. This is a great tip. Doing this will help make any seal last longer. Also check the metal chamfer around the outer edge. These chamfers tend to have burrs which, if not filed down, can nick the seal during installation, causing premature seal failure. Chapter 2. Reassembly. Once all the components have been disassembled, inspected, and cleaned thoroughly, it's time now to reinstall the wheel end. Begin by lubing the inner bearing with the same lubricant you are using in the hub. Note that if you are using semi-fluid grease or hard-packed grease, you will need to pack the bearings with that same grease. Have you ever installed a seal only to realize that you forgot to insert the inner bearing? Mistakes happen, but if you have to remove the seal for any reason, it is important that you do not try to reuse that same seal. You should replace that seal with a new one every time. Always make sure you are installing the right seal for the hub you are working with. RevHD seals have a part numbering system that tells you if the seal is designed for a steer, drive, or trailer. We also indicate the type of spindle and list an interchange below our part number. We utilize this same part numbering system for our other components as well. If using a seal other than RevHD, check that seal manufacturer's interchange to ensure you're using the proper seal for the hub you're working with. All RevHD seals are sealed in plastic wrapping. If you are using a seal that is not sealed in plastic, take note of any dirt or contamination that may have made its way into the seal while it sat on the shelf or was delivered to your location. Also examine the seal for any signs of dry rotting. Depending on the temperature and the age of the seal, some seals that have not been sealed in plastic can exhibit signs of dry rotting, which could cause the seal to fail prematurely. RevHD seals are also the only seals that come with a special formula designed to cause the rubber to swell slightly after installation. This allows the rubber to fill in any imperfections on the hub bore or the spindle shoulder. This special formula also helps protect the rubber over time. Using this included formula is not required, but it is recommended as it is designed to make any seal last longer and is particularly helpful for older equipment. RevHD recommends that you place a small amount of this special formula around the OD of the seal just prior to installing the seal. Then put a small amount around the ID of the seal just prior to docking the hub. When installing a seal other than RevHD, you will need to make sure you have the proper tool to install the seal. Most seal manufacturers design specific tools for each specific part number. Using a tool other than the one designed by that seal manufacturer can damage the seal upon installation and cause premature seal failure. If you do not have the proper seal installation tool for the seal you're installing, or if your tool has been dropped or damaged, contact the seal manufacturer for a replacement tool. One of the best selling points of the RevHD seal is that you do not need an installation tool to install it. The RevHD seal is uniquely designed to be installed with any flat, clean instrument. This is because the top plate of the RevHD seal is the tool. The good news is this top plate tool remains with the seal after installation to further protect the seal while you dock the hub or from the elements and heat from the brakes once the vehicle leaves the shop. Note: if you are using a seal installation tool on the RevHD seal, make sure to flip the plate over so that only the flat side makes contact with the seal. This is very important. Most seal installation tools are shaped specifically for certain brand seals. Using a seal installation tool without flipping the plate over can damage our seal. Also, do not use tools with a bearing guide on the RevHD wheel seal. Lastly, because RevHD seals are wider, you may notice that our seal protrudes out of the hub in certain configurations. Never try to force the seal past the point that it has bottomed out in the hub. Doing so can cause the spring inside the seal to become disengaged. Make sure to lube the spindle with the same lube you are using in the hub. Also, go ahead and lube the outer bearing and have it close by to insert after docking and filling the hub with lubricant. Take great care when docking the hub to ensure that the spindle does not hit the face of the seal. If the tires are on, use a wheel dolly and line everything up so that the seal and the bearings go uniformly over the spindle and into position. Note: if you hit a burr or the hub does not want to go over the spindle easily, do not struggle or wrestle with the hub to get it into position. This can caulk or damage the seal. Instead, allow the bearing adjustment to seat everything for you. The bearing adjustment will seat the seal onto the shoulder far more uniformly than you can do it by hand. Another important feature of the RevHD seal is the unique flex design, which can help prevent failures commonly caused by caulked seals. Sometimes seals can get caulked during installation or while docking the hub. Other times they can caulk because the vehicle goes off-road. The RevHD seal's unique flex design allows the seal to flex in critical situations, protecting you from leaky seals caused by tilting or caulking. Of course, before inserting the outer bearing, make sure that you pump lubricant into the hub. If using oil, fill the hub bore up until the oil is just starting to trickle out. If you're using semi-fluid grease, you will need to fill the hub halfway. This can sometimes be difficult as the lubricant tends to waterfall out before you get it to the proper fill level. The RevHD seal box comes with a tool on the back that will help with the hubs using semi-fluid or synthetic grease. Simply cut the half circle that matches the part number of the seal. The box then holds the grease in place while showing you the exact amount of lubricant required for the hub. Once you have the lubricant at the full line, simply insert the pre-lubricated bearing while simultaneously pulling the cardboard template out of the way. There is no mess on the floor, and you always know you have the proper amount of lubricant in the hub. If using hard-pack grease, fill the hub entirely, leaving just enough space for the spindle. Note, having the outer bearing already lubed and ready to install will make things easier after you dock the hub. Chapter 3. Bearing Adjustment. Now you are ready to perform your bearing adjustment. This is without a doubt the most critical aspect of assembling the wheel end, not only because an improper bearing adjustment can cause seals and bearings to fail prematurely, but because a bad bearing adjustment can cause a wheel off, a fire, or other major catastrophe. Pay close attention to this part of the course, as we will attempt to go over all the various nut systems that exist today and show you the bearing adjustment procedures that are associated with each of them. We will begin by showing you the proper bearing adjustment procedure for the double nut system on a conventional, manually adjusted hub. Then we will show you how to perform a proper bearing adjustment on a single nut like RevHD's RevLock Universal Spindle Nut. Later, we will show you what to do with pre-adjusted hubs containing a spacer between the bearings. For a double nut system on a conventional hub, you will need to follow the TMC RP618 chart and count the threads per inch on your spindle. You will also need to measure the outside diameter of the jam nut to conduct the proper bearing adjustment for the spindle manufacturer you are working with. Begin with the torque of 200 foot-pounds. Rotate the hub a few times and then click the torque wrench again. Next, back the inner nut off until loose. Now go back with 50 foot-pounds. Again, rotate the hub and click again. The final back off of the inner nut will be either a quarter, a half, or a sixth of a turn, depending on the TMC chart and the thread count on the spindle you are working with. A copy of this chart will be found on the RevHD website. Next, place the washer into position. If the dowel pin does not line up with the hole, flip the washer over. If neither side lines up, choose the side that comes the closest and turn the inner nut looser, not tighter, until the dowel pin lines up. Lastly, install the outer jam nut. Once again, refer to TMC's RP618 for the true final torque. Depending on the size and type of nut, the final torque can be anywhere between 250 to 350 foot-pounds. Note a torque wrench and socket capable of achieving a torque spec of 350 pounds will be needed. Afterwards, check your work with the dial indicator. If adjustments are needed, remove the outer nut, star nut, and washer, and then tighten or loosen the inner nut as required. Then reassemble and retorque the jam nut to the appropriate foot-pounds. If all this sounds complicated, there is an easier way. Introducing the RevLock Universal Spindle Nut, a single nut designed by RevHD in cooperation with Temper Corp and manufactured right here in the USA. This RevLock Universal Spindle Nut works with all systems, including TMC RP618, pre-adjusted hubs, or the Dr. Preload tool. The hash marks represent the correct back-off for manually adjusted hubs. The dimples indicate 1/1000th of in-play adjustment. The reusable retainer ring is removed by squeezing the finger tabs together and then disengaging the center tab from the nut. To install on a manually adjusted hub, thread the RevLock nut onto the spindle until it stops against the outer bearing. Now you can utilize the simple formula 2-1-1. Begin by torquing the nut to 200 foot-pounds while spinning the hub in either direction. Next, back the nut off until it's loose. Now, torque the nut to 100 foot-pounds while spinning the hub in either direction. Now, back the nut off 1 hash mark. The final back off is always 1 hash mark. This will give you the same back off as if you had counted the threads per inch and utilized the TMC chart, except that we have done all that math for you. We pre-stamp the nut so you don't have to count the threads per inch, measure the spindle, or the nut. Some RevLock spindle nuts will have 4 hash marks. Others will have 3 or 8 hash marks, depending on the application. Backing the nut off 1 hash mark will precisely adjust the nut to TMC RP618 guidelines and leave you with the perfect bearing adjustment every time. Introducing the new RevHD line of Rev sockets. These sockets are designed with higher torque ratings than other sockets on the market. Additionally, the hash marks for the RevLock spindle nut are printed directly on the socket, allowing you to use the 2-1-1 method with most nuts on a manually adjusted hub. Install the retainer ring at an angle, ensuring the center tab locks into the teeth of the nut. Next, squeeze the finger tabs to engage the legs into the nut. Lastly, check to ensure the retaining ring is fully engaged into the nut. If engaged completely, none of the Easy View notches should be visible. Note, if a proper bearing adjustment has been performed on a manually adjusted hub, the nut will always be hand tight upon completion. Using a dial indicator, you will find you are left with 1 to 5 thousandths in play every time. Many technicians will want to tighten the nut more in an effort to err on the side of caution. This is putting a slight crush or preload on the bearings, and you will have a bearing adjustment that is too tight. Using 2-on-1 with the RevLock Universal Spindle Nut guarantees perfect bearing adjustment every time. For pre-adjusted hubs containing a spacer between the inner and outer bearings, the procedure is always 1 torque with no back-off. However, the amount of torque will often differ depending on the manufacturer of the pre-adjusted hub. Whether you are using the RevLock nut or another manufacturer's nut, always torque the nut 1 time with no back-off. Note, most spacer manufacturers recommend replacing the spacer every time you reinstall the hub. RevHD offers replacement spacers made with incredibly tight tolerances to make the proper torquing of pre-adjusted hubs a breeze. And the good news is, the proper torque spec is printed right on the outside of the spacer, so you always know the correct amount of torque to apply to the hub you are working with. Best of all, Rev spacers have a part number that matches the RevHD seal, nut, and other components, so you always have the confidence of knowing you have the right spacer for the application. Note, it is very critical to know that the half-stand bearings that come with pre-adjusted hubs cannot be mixed with standard bearings. The half-stand bearings are capable of running at 0 end play. Standard bearings are not designed for pre-adjusted hubs. RevHD only offers bearing sets with the tighter half-stand tolerances. We do this to keep things simple. Half-stand bearings are compatible with both pre-adjusted and manually adjusted hubs. This means that with RevHD bearings on hand, you can confidently use them for any hub application. Note, if a proper bearing adjustment has been performed on a pre-adjusted hub, the nut will not be hand-tight upon completion of the procedure. Instead, you should be left with 0 end play. Perhaps the most important recommendation we can make in this training video is to use a dial indicator every time you complete a bearing adjustment on any wheel end. All wheel end experts agree that using a dial indicator after completing a bearing adjustment is the only way to ensure that you have not introduced any human or mechanical error into the wheel end. If everything is correct, you should have between 1 and 5 thousandths in play on a manually adjusted hub and 0 in play on a pre-adjusted hub containing a spacer. RevHD recommends utilizing TMC procedures for all wheel end installation practices. If you are ever uncertain about the installation practice for any particular manufacturer, we recommend contacting that manufacturer for detailed instructions on how to install their components. You can contact RevHD toll-free at 844-REV-SEAL. Chapter 4. Lastly, if working on a steer or trailer spindle, it is time to install the hubcap. If using the old hubcap, use a new gasket and always check the hole in the center of the plug to make sure that it is clear and free of debris. Install each bolt in a crisscross pattern following the manufacturer's torque specs. The RevHD Severe Duty Hubcap comes with all new bolts and a gasket. We recommend tightening each bolt between 12 to 16 foot-pounds. Staying with this torque ratio is particularly important for the heat check bolt that is included with each RevHD hubcap. Now, if it is an oil hubcap, fill the hubcap between the add and full lines. Note that it is important to rotate the wheel several times to make sure that when the oil settles, it remains between the add and full lines. It is recommended that you inspect the wheel end annually by removing the hubcap and checking for metal flakes or water contamination. Then recheck end play before reinstalling the hubcap. Other important points. In addition to inspecting and cleaning all components, it is also important to inspect and clean all installation tools. Chapter 5. Let's recap what we have learned. Remember, there are 5 leading causes of wheel end failure. 1. Improper installation. The top plate of the RevHD seal is the tool and can be installed by any flat, clean object. This same top plate tool continues to protect the seal while docking the hub and after the vehicle leaves the shop. Our unique flex design will also help protect you against cocked seals. 2. Incorrect bearing adjustment. Using the RevLock universal spindle nut and the 2-1-1 formula on a manually adjusted hub ensures a proper bearing adjustment every time, no matter the spindle manufacturer or thread count. If using the double nut system, refer to TMC's RP618. If using a spacer, check the manufacturer to ensure you have the correct torque specs. 3. Contamination. Always make sure every component is cleaned thoroughly, and don't forget to clean the spindle shoulder all the way back. 4. Worn or damaged components. If you have wear or other imperfections on the shoulder or hub bore, RevHD's included tube of Seal Extend will ensure that the rubber on the seal swells into those areas to prevent leaks. If you have questions surrounding any other component, replace it. 5. Clogged vent hole, either on the hubcap or the drive axle vent. The RevHD hubcap comes with a clog-proof vent hole. If using another manufacturer's hubcap, check the vent hole periodically to ensure proper ventilation. Now that you have viewed this training video, you may proceed to the RevHD website at revhd.com to take a short quiz to determine your wheel end knowledge. A passing grade of 85 or better will earn you a certificate of completion, which will be emailed to the address you enter when you begin the quiz. This same certificate earns you a RevHD seal warranty that includes your brakes. Thank you for viewing this video. To find out more about RevHD products and where to buy them, visit revhd.com.